Hi, and welcome to another lecture on ordinary differential equations. Today we are going to do an example of solving an ODE with method of substitution. We are going to look at Bernoulli's equation for this example. So let's go look at our problem. We said in the previous previous lecture, that Bernoulli equations have the following form. There's a y prime and a y and then y to some power other than 1, and there could be some coefficients as a function of x. The example that I'm going to do today is going to be written as, say, t squared plus t squared y prime plus 3t y minus y cubed is equal to 0. We are going to solve this, and you notice that in comparison with that, n happens to be 3 in this case, and I'm using the independent variable t just so that we have some examples not relying on x all the time. So as we said last time, the substitution to be used for this type of problems is y to power of 1 minus that exponent. So in our example, substitution is y to power of minus 2, because 1 minus 3 will be minus 2. Now to substitute, perhaps the easiest thing is to take this equation and divide all of it with y cubed first. So I get t squared y prime over y cubed plus 3t y over y cubed, and then minus y cubed over y cubed is equal to 0. Clean this up. I have t squared y prime y to power of minus 3, and then this is 3t y to power of minus 2. This is simply just 1. Now we realize what's the role of this y to power of minus 2. If I differentiate this by the power rule, I get minus 2 y to power of minus 3 then times y prime. So y to power of minus 3 y prime is going to be w prime over minus 2. So this expression here is t squared or w prime over minus 2. Then I have 3t y to power of minus 2 is just w, and then minus 1 equal to 0. Now we recognize this as an instance of integrating factor problem. The nonlinearity is gone. It's a first order equation which is linear, and we can approach it by integrating factors. So what I will do, let's clean up by multiplying with minus 2 first. So t squared w prime minus 6t w plus 2 is equal to 0. I rearrange it so that it conforms the style that we had before. So I divide by t squared. It becomes w prime minus 6t over then t squared w, and then I take my 2 to the other side, minus 2 over t squared. Cleaning up one more round, I have w prime minus 6 over t w is equal to minus 2 over t squared. So that's exactly falling in the category of first order equation that we could solve by method of integrating factor. What was our integrating factor? It was exponential of integral of this coefficient. When we made sure that the leading coefficient is 1, all I need to do is to integrate the second coefficient and then exponentiate that. So the integral is exponential of minus 6 logarithm of t. Let's assume t is positive. Then I can write this thing as exponential of logarithm of t to power of minus 6. And exponential of logarithm is just that expression t to power of minus 6. So that is the power that I should multiply this whole equation with. So I'm going to write t to power of minus 6 w minus t to the power of minus 6, and I have 6 over t w is equal to t to power of minus 6 times minus 2 over t squared. We might as well write everything in similar notation. So t to power of minus 6 w minus 6t to power of minus 7 w is equal to minus 2t to power of minus 8. Okay. If you have done everything correctly, this has to be a complete derivative. Derivative of w times t to power of minus 6. Let's double check to make sure. W prime times the first term. Derivative of the second term is minus 6t to power of minus 7. And the right hand side I have my t to power of minus 8. I integrate both sides, so it becomes t to power of minus 6w is equal to, this is going to be minus 2 t to power of minus 7 over minus 7, and then a constant. We might as well go ahead and divide both sides to multiply by t to power of 6. So I'll have w is, canceling the minuses, I have 2/7 t power of minus 7 multiplied by t to the 6. So w became 2 over 7 t plus c t to power of 6. Okay, what was w? Remember, w was y to power of minus 2. So we go back and try to find y itself. So y to power of minus 2 is 2 over 7t plus ct to the power of 6. Reciprocate both sides, so this becomes y to squared is equal to reciprocal of that. At this stage, different people have different styles of simplifying this. Feel free to take common denominator and clean this up further. Y, take a square root, so I'll have a plus or minus, and then square root of 1 over 2 over 7t plus ct to the power of 6. So I recommend that you try to do this problem second time around all by yourself and then compare with the answer we just got. And it would be instructive to also go ahead and graph this thing on decimals and see what you get. Okay, it was a short lecture, but the algebra is a bit more advanced than before, so please practice the problem by yourself, and then there will be some homework problems similar to this. Good luck and God bless until our next lecture.